Hello everyone, my name is Ruslan. I am founder and CEO of Gelastic, and today we will talk about an interesting topic, containers live migration, how it works behind the scene. We believe this topic is very interesting because demand on live migration is growing, and live migration opens new opportunities and gives more freedom. So if we think about live migration in terms of analogy, the good analogy will be a portal. So you jump into a portal and you exit somewhere. You travel across the distance very fast. So live migration is very similar to this analogy. Okay, what kind of problems we try to solve with live migration? There are several of them. First of all, hardware maintenance. So, for example, when sysadmin guy needs to upgrade hardware, it's very painful to migrate all customers from one hardware node to another hardware node. And in many cases, it's just impossible. So some downtime might happen during the maintenance. Another problem is unbalanced cluster load. For example, you have several servers in your cluster, and one hardware node is overloaded, and another one does not have too much load. So it will be very useful to have some easy option to rebalance the load. And again, today it's not easy to do. And one more, troubles within a cloud. As you know, there are so many clouds on the market today, and sometimes they have downtime. And if you don't like your cloud provider, you should have an option to migrate your applications easily from one cloud provider to another one. So all of these problems can be solved in different ways. Let's analyze what kind of solutions we have on the market today. First of all, it's planned downtime. For example, if you want to do a maintenance for a cluster, you notify your users in advance about planned downtime, and you shut down hardware, add, fix everything you want, and after that, restore it back. The issue here is the relatively big, long downtime frame. Another one option is traffic rerouting. So, for example, you want to do a maintenance, you restore a copy of your application on another hardware node, and you reroute traffic to this new copy, and shut down previous one, do some maintenance, and restore it back. The issue here is the complexity. So your application should be designed to handle availability and synchronization, data synchronization. So one more solution is microservices. So microservices helps us to avoid downtimes when some part of your microservice application fails. So your application will continue to work, and failed containers will be restored on another hardware node. So microservices helps you to avoid downtimes during the maintenance window. However, the issue here is again complexity. You need to design your application properly and to manage availability and restore after the fail. And the last one we know is the live migration. So actually we will talk about live migration and how live migration help to solve the downtime issues. For example, how we can use live migration for hardware maintenance. As you can see on this illustration, we have one virtual machine, small one. It can be actually hardware node as well, physical hardware node. So, and the load is growing on this virtual machine, and when it's close to 90%, for example, you can migrate all containers inside this virtual machine to another virtual machine. It can be a bigger virtual machine or at least the same size, and you can do maintenance on the previous virtual machine. So live migration, as you can see, helps us to avoid downtime. You can, again, migrate all containers from one to another one without downtimes. Load rebalance. Let's say again, like we have one physical node and load is growing, more and more applications, more and more containers provisioned on this physical hardware node, or some containers started to grow vertically. You can migrate some containers from this physical hardware node to another physical hardware node. So you can do rebalance. You can automate this process actually to check periodically the load of each hardware node, and if load is more than specific threshold, you can migrate containers automatically. Okay, let's talk about technology and let's analyze how it works from technical point of view. As you can see on this illustration, we have two nodes, source node, where our container is placed, and destination node, where our container will be placed at the end of the live migration. When we want to migrate a container, platform freezes this container and gets the state of this container, I mean memory, file system, actually memory and file system. All connections, network connections, and so on. So orchestration platform gets the whole state of the container. After that, platform copies the state to destination node, restore everything in the same mode, and unfreeze the container. And at the end, there is some cleanup at source node. So, as you can see, it's pretty straightforward. So you get the state, you copy the state, and you restore the state. But there is a time frame, like frozen time frame, and we need to consider this time frame during the application architecture design, because for some application it doesn't matter, like I mean small time freeze doesn't matter. For some application it might be an issue. There are two kind of solutions for live migrations. One of them is the pre-copy memory, and how it works. When you want to migrate a container, platform turns track memory on source node and copies this memory in parallel to destination node. So, and it copies to the state when difference is very small between source node and destination node. So at that time, when the difference is small, platform freezes the container, gets the rest of the state, migrate it to destination node, restore it, and unfreeze it. And again, a little time frame for cleanup. The same, you can see there is a frozen time. In average, again, it depends on different kind of applications, but in average, it can be between like 5 and 30 seconds. So please take into account that your application might be frozen for 30 seconds, but it's a very small time frame compared if you shut down the whole hardware node, like, and you know, like upgrade everything and restore it again, so it can take hours. Another solution is post-copy memory, or in other words, lazy live migration. So how it works? We freeze container at the source node at the beginning, get the state, the most fast changing state, move the state to destination node, restore it, and unfreeze container. And after that, we copy the rest of the state from source node to destination node. So This is the reason why we call it lazy live migration. At the beginning, you migrate the most fast-changing data, the most fast-changing state, and later you copy the rest. Okay, how we can use live migration for DevOps and how we can improve our DevOps with continuous live migration. Let's analyze current solutions that we use with Docker containers. So there is a hub registry. If you know, it's a place where many different container templates are placed. And we have like dev environment, test environment, stage environment, and two productions. So for example, I want to deploy a Java application. So what you do, I pull a Java container from hub registry with my application and provision this container on my local machine. So deploy my application, test it, and if everything is okay, I commit back the latest version of my application to hub registry. And after that, I call test guys or send them a message or automatical system triggers the process. This latest application can be provisioned on test environment. So you pull it to test environment. And after that, you pull it to stage environment, check it. If everything is okay, you pull it from production, from first production, and from second production. So pretty clear how it works. It works for many companies. How we can improve this pipeline with live migration. So as you can see, topology became different. We have hub registry where we place all our containers template. And we want to update our application. So we pull this template from dev environment, from hub registry to dev environment, provision, make some changes, commit it back. And after that, we can migrate the whole container from dev environment to test environment. And test guys can check if everything is okay, and after that to migrate from test to stage. And sysadmin guys can again make sure that everything works properly and migrate it to one production and to another one. Actually, as you can see, there is a clone option as well. So you can even clone your container and migrate it in live mode as well. So why it's better compared to the previous one? As you can see, you don't need to reprovision your container each time when you migrate from one stage to another stage. So it can simplify significantly your DevOps pipeline. And second one, you don't need to connect all your stages to hub registry. Maybe some security regulation rules do not allow you. So think about these both pipelines and choose which one works better for you, or mix and match them both. What kind of use cases we have with live migration? First of all, is the most obvious one, live migration inside one data center. As we discussed previously, for example, a sysadmin guy wants to do maintenance of hardware. And this sysadmin can migrate all containers from one physical hardware node to another one inside one data center. Or even end customers can use different availability zone in one data center. So cloud service provider can provide you a couple or three or more availability zones inside one data center, and you can migrate your applications in live mode across these availability zones. So again, it's easy. You don't need to reprovision everything. You don't need to shut down your application. So there is no downtime for end customers. Second one, across multiple data centers of one vendor. Almost the same, but the difference is data centers are located in different regions, physical buildings, so it's a little bit more complex to implement because you need to deal with networks. But it works nicely if you configure it properly. So you can benefit from live migration across multiple data centers of one vendor. And the last one is live migration across multiple data centers of different vendors. This is the most difficult part, actually. For example, let's imagine you are using Amazon and you got nice bonuses from Azure and you want to benefit from these bonuses. So if you have a solution to migrate all the applications by one click from Amazon to Azure, I am pretty sure you would love to use this option because you can save money, you can benefit from features that Azure provides and, for example, Amazon does not. So, but again, it's not easy to implement without, specific knowledge. So let's talk a little bit more about multi-cloud benefits. Why we believe it's important for end customers today. First of all, autonomy. Autonomy allows you not to be locked to a specific platform, to any of them actually. And as we know, it's a promise of Docker containers. So to be independent from different vendors, you can easily provision the same containers on different vendors. If you don't like one of them, you can provision the same container on another one. We believe live migration can simplify migration across different providers even more. So it gives you even more freedom and flexibility without significant efforts on your side. Hybridity, one more important again, like you can mix and match different cloud vendors to optimize cost for your business. For example, for a production applications, the most likely you will prefer to choose a cloud provider with very good performance and stability, but this provider most likely will cost you more compared to other highly performed service providers. So you can, again, like for dev environment, you can choose a cloud provider with a cheap hardware. Maybe they don't have high uptime or they don't have high performance hardware. But for dev environment and test environment, it can work for you. You can benefit from this as well. And live migration can help you to move across different vendors with different hardware easily. And of course, havability in disaster recovery. So as we all know, it's not easy in some cases, actually in the most cases, to implement havability in disaster recovery. We believe live migration can help to achieve havability in disaster recovery much easier and faster. Well, let's talk about evacuation scenario. For example, we have a set of applications, a set of containers on Amazon, and tomorrow something happens and you don't like Amazon anymore, or you just like Azure more than Amazon. So what you do, you configure properly network connection between two clouds, and after that you can evacuate all containers by a click from one cloud to another one. So it works like a magic, but it works. I will show a demo today how it works, and we believe it's very powerful. It gives us flexibility. It gives us power of choice. One more use case, like multi-cloud DevOps pipeline. I mentioned it early. So you can have development and test environment at one cloud provider and like pre-production and production at another one. cloud provider. And you can migrate, as you can see, multi-container environment pretty easily. So bottlenecks and hidden issues that we need to take into account. First of all, some performance degradation. Yes, during the live migration, you can notice some performance degradation. For some applications, it's critical, let's say like heavy loaded real-time applications. So they don't accept any like performance degradation. But for majority of applications in the internet, it doesn't matter, specifically for web applications. This performance degradation happens during freeze time, when your application is frozen. Again, like for web applications and many for mobile applications, I mean mobile backends, it doesn't matter in the most cases. Another one challenge is related to big data and fast changing data. So it's not easy to migrate big data from one cloud provider to another one. Sometimes it's easier just to move the whole hard drive here, but we are working on this direction as well and analyzing several options how to implement migration of big containers with big data and fast changing data inside. So public IP in multi-cloud, another one issue, you cannot migrate containers of public IP address from Azure, let's say, to Amazon or from Amazon to Azure, because, you know, like these cloud providers, they keep this IP address inside their network. So what is the solution in this case? You just don't use public IP addresses. You use load balancing and internal IP addresses, and you don't need public IP address in this case, and there is no issue for you. And one more solution, some service providers, they provide ability to migrate public IP address across different data centers. But again, it's most likely across different data centers of one vendor. If we're talking about different vendors at this moment, we don't know a solution how to migrate public IP address. What do we hear from the market today who is offering live migration? So there are two different, I would say, like products that are using live migration or kind of products. First of all, it's a containers engine with live migration. So the most famous one is OpenVZ. This solution, these guys actually created live migration. They were pioneer in this direction, and they have very nice solution today, and it's production ready. It works nicely. One more, which is coming to the market, is runc. It's Open Containers. It's a solution from Open Containers Standard Initiative. So this guys is implementing containers engine with live migration as well. What kind of containers orchestration with live migration we have on the market? Of course, Elastic. We are using containers live migration since 2011. Collected a lot of experience and a lot of feedback from end customers. And second one, orchestration is Docker, creates their own orchestration with live migration as well. It's still not available yet, but we know they're working hard on this, and we hope they will get success in the near future. So it will be more widely used by many other companies. And now, demo. I would like to show some demo how to migrate Minecraft, very popular game, from Amazon to Azure in live mode without downtime. So let's jump to my browser. As you can see here, it's Jelastic Developers Self-Service Portal. And I have already pre-created many different environments. You can see Magento cluster, you can see Minecraft, some Payara micro cluster. So let's launch our game, Minecraft. Okay. So this is the progress. Here we can choose the latest version of Minecraft. Just play Minecraft 1.9. Okay, so our Minecraft client is ready, but we need to connect to our server, and I have provisioned Minecraft server here, you can see. So what I need to do, I need to get endpoint of this cluster and just add configuration into Minecraft, add a server. Let's say like webinar LM demo. Done. Yeah. So our server is live, and now let's connect. Okay, now I'm inside, so I can run and so on, walk. Now let's migrate this application from Amazon. Actually, you can see this server is on Amazon right now, but we can migrate it to Azure pretty easily. I press a button, like region button, and I can choose different regions. Like you can see Microsoft Azure, and we have pre-configured live migration across to these regions, across to these clouds. And I choose Microsoft Azure as a destination node, target region, press button, and migration now is in progress. So let's back to the game. Let me move my window a little bit here. And we can walk. So let's play a little bit. I'm not super experienced in Minecraft actually, but you can see everything is live. So there is no downtime and my application is in progress. I mean live migration is in progress. So it will take about like 1 or 2 minutes to finish live migration progress. And I will walk during all this live migration and try to mine something. So actually what I can mine? Some flowers. Yep. Flowers. Let's mine some trees. Oh, you can see we got notification here. Our environment has been successfully migrated to Azure, and you did not notice any downtime. I was playing in Minecraft and so on. Yeah, you can see right now this is on Microsoft Azure. I can migrate back from Azure to Amazon, again, just by a click. And again, let's back play a little bit more. So now you can imagine you have your server, like game server or web application, and a lot of customers are playing inside your server or requesting some information from your server. And you can migrate this server from one cloud to another one without downtime. You don't need to notify your end customers. You don't need to spend a lot of effort to prepare like migration, to verify everything, and double check. You just press button and it will be migrated to another cloud. Very useful. We believe it's one of the most powerful solutions related to containers today on the market. Okay, I believe in 30 seconds it will be finished. Oops. Find something. Yes. Our server has been migrated to Azure, to Amazon back, as you can see. Easy. Okay, one more demo. So I have Magenta cluster, and it's highly available cluster with two Nginx as load balancer, with two Nginx as application servers. Let me switch off the game. So Nginx as application server, memcached, and two MySQL servers and Redis. So pretty complex topology with 2, 4, 6, 7, 8 containers inside. And I can open it. And you can see it's my homepage of Magento. And now I can migrate it from OVH to like OVH2. You can see there is a live migration between these two regions. And I just press button. And that's it. My application will be migrated in, let's say, like 2-3 minutes from one region to another one. Easy and useful. Okay, guys, so if you like to get more details about how it works or to get some test drive of live migration inside the cloud or across the clouds, feel free to drop us a message and explain your needs, and we will be happy to help you and to share our knowledge and experience. So thank you very much for your time, attention, and good luck.